Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and XST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 4, Refraction of Light at Plane Surfaces. We'll be discussing the topics critical angle and total internal reflection. Are you ready? Let's start. We have studied all about refraction in detail and the application of refraction in the previous classes. What is refraction? Refraction is the bending of light when light travels from one medium to other. If a light ray travels from a rarer medium to denser medium, what happens? Here you have the normal. This is your incident light ray. This is the actual path of the light ray. What happens to this light ray? It bends towards the normal. Okay. When a light ray travels from a denser medium to rarer medium, what happens? It bends away from the normal. This is the actual path. It bends away from the normal. We know this. So here, today we'll be considering only this case. That is a light ray which is traveling from a denser medium to a rarer medium. Transmission of light from a denser medium to a rarer medium at different angle of incidence. When angle of incidence is increased, what is happening? Let's see, okay. So, first case is when the angle of incidence is small. For small angle of incidence, here we have a C. This C is called critical angle. We'll understand what critical angle is. So, take this case. Here you can see this is your denser medium, glass, and air is your rarer medium. Okay. Here we have the incident light ray. Incident light ray. Light ray is going from the denser medium to rarer medium. AO is your incident ray. Now, what happens to this incident ray at the medium separation? Here we have the separation of two media. Okay. Here what happens to this light ray? Partial reflection and refraction both takes place. Okay. Now here I is your angle of incidence. AON is your angle of incidence. NON dash is the normal. Then you have reflection angle and refraction angle. You can see, right? So we know that the angle of incidence and angle of reflection will be same. Okay. We have studied the laws of reflection, where we have the angle of incidence to be equal to angle of reflection. What about refraction? It is not necessary that angle of incidence and angle of refraction should be equal. Angle of refraction will be greater than angle of incidence. What is the reason here? Light is traveling from the denser to rarer medium. Okay. Here BON dash is your angle of refraction, the angle between refracted ray and the normal. Okay. Now what is happening? You have a light ray making a small angle of incidence, okay, an angle which is less than C. C is a critical angle. What happens? You are getting refraction. So now you have to remember one point. When the angle of incidence is increased, okay, when angle of incidence is increased, here for the small angle of incidence, we have both reflection and refraction. Refraction is more, okay. When this angle is increased, what happens is the refraction will decrease and reflection will increase. Okay, clear? So, we will be checking other cases. Here, when you checked with the first angle of incidence, that is an angle of incidence I which is less than the critical angle, we are getting reflected angle and refracted angle. Both is happening. Reflection and refraction is happening. And this is your refracted ray such that the angle of refraction is greater than I. Okay. Now, let's take the second case. Second case is when the angle of incidence is equal to critical angle. I is equal to C. So, here we will understand what this critical angle is. We said the angle of incidence is increased. We are increasing the angle of incidence. Okay. For small angle of incidence, we got refraction angle of refraction to be greater than I. Here again, when the angle of incidence is increased, refraction angle also will increase. Okay, with increase in angle of incidence, angle of refraction angle will also increase. The necessary condition is angle of incidence and angle of reflection. Here you have both reflection and refraction. Angle of incidence and angle of reflection will always be equal. Now, what you have to remember is, at some point, at some angle of incidence, the refracted angle will become equal to 90 degree. Okay, here you can see the refracted ray. What is this? Here the refracted ray is passing through the separation medium. Okay. Here we have the plane of separation and the refracted ray is passing along the surface of separation of the two mediums. Okay, you can see. Now what is the angle? Here we have the normal. This is your plane of separation, which means the angle made is equal to 90 degree. So when the angle of refraction angle becomes equal to 90 degree, at that point you will be having an angle of incidence. At some angle of incidence, for a particular angle of incidence, the refracted angle becomes equal to 90 degree. This angle of incidence will be equal to critical angle C. Okay, angle of incidence will be equal to critical angle when refraction angle is equal to 90 degree. Okay, so understood what is critical angle? How can you define critical angle? So here, when angle of refraction is 90 degree, angle of incidence is called the critical angle. Okay, critical angle is the angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium is 90 degree. Okay, it is the angle of incidence which is in the denser medium. Angle of incidence will be in the denser medium. Why? Because we know that the light is traveling from denser to rarer medium, which means the angle of incidence will always be in the denser medium. Okay, here we will be having angle of incidence to be equal to critical angle, and the refracted angle is 90 degree. Only because the refracted angle is 90 degree, we are getting an angle of incidence. This angle of incidence is called the critical angle, and here we have the definition for critical angle. Light should travel from denser to rarer medium. This is the most important condition. Okay, if light is traveling from rarer to denser, then this won't happen. Okay, now this is our third case, when the angle of incidence is greater than the critical angle. We discussed two cases. First, when the angle of incidence is less than critical angle, and second, when angle of incidence is equal to critical angle. So here we have said that when the angle of incidence is increased, when angle of incidence increases, refraction will decrease and reflection will increase. Okay, so at a particular angle of incidence, we got the refracted ray to be moving along the surface of separation of the two medium. Okay, that is angle of refraction we got equal to 90 degree. Now, beyond that, we are increasing. Beyond that, if we are increasing the angle of incidence, what happens is there is no refraction taking place. Okay, there is no refraction or there is zero refraction. Refraction won't happen. There is only reflection. The light ray will bend and come to the same medium. Okay, pass through the same denser medium. Okay, this reflection is called total internal reflection. Okay, so when angle of incidence is increased such that it is greater than the critical angle, there is no refraction taking place, there is only reflection, and this is your reflected ray. Since there is reflection, we can say that the angle of incidence and the reflection angle will be equal. Okay. Next is the relationship between critical angle and refractive index. Here we have taken the second case, that is when angle of incidence is equal to the critical angle, we know the angle of refraction will be equal to 90 degree. Here we have two mediums. This is your denser medium and this is your rarer medium. Okay, light is traveling from the denser medium to rarer medium. AO is your incident ray, which is incident on the separation of two medium. Okay, here what is happening? Reflection is happening and refraction is taking place. The refracted ray will be passing along the plane of separation of the two mediums. Okay, now we have studied the laws of refraction. We have sin I by sin R is equal to a constant, which is refractive index of second medium with respect to first medium. Okay, here the second medium is air and the first medium is glass, which is equal to mu Ag, refractive index of air with respect to glass. Okay, what is the angle of incidence in this case? Here angle of incidence is equal to the critical angle. Therefore, this can be written as sin C divided by refraction angle. Refraction angle is equal to 90 degree. Sin 90 degree equal to mu Ag, refractive index of first medium, refractive index of second medium with respect to first medium. Okay, now what is the value of sin 90 degree? Sin 90 degree is equal to 1. Therefore, we are having sin C is divided by 1 is equal to mu Ag. Okay, now we have studied the principle of reciprocity, according to which mu Ag will be equal to 1 by mu Ga. Why? We have refractive index of second medium with respect to first medium is equal to 1 by refractive index of first medium with respect to second medium. Okay. Therefore, mu Ag will be equal to 1 by mu Ga. This can be written as sin C is equal to 1 by mu Ga. Okay. Or mu Ga, that is refractive index of glass with respect to air is equal to 1 by sin C. Okay. So, if you know the critical angle, we can find the refractive index of the first medium, or you can find the critical angle just by taking the sine inverse. Okay. After finding what 1 by the refractive index of second medium with respect to first medium is, you have to take the sine of it, you will be getting sine inverse of it, you will be getting the critical angle. So, in order to find critical angle, just we need to know what is the refractive index of the denser medium. Clear? So, this is the relationship between critical angle and the refractive index. For example, you need to find the critical angle for a pair of medium, air and glass. Okay, air, glass, medium. If you are going to find the refractive index, we are taking an example. We know the refractive index of glass with respect to air. What is the value? Which is equal to 3 by 2 or 1.5. Okay. We have the relation sine of the critical angle is equal to 1 by refractive index of the medium, refractive index of the denser medium. Here the denser medium is glass, which is 3 by 2. Or this becomes equal to 2 by 3. Sin C is equal to 2 by 3. Okay. From this you can find the value of C. Taking the sine inverse of 2 by 3, you will be getting a value. You can use the calculator and find, and the C value will be equal to, angle C will be equal to 42 degree. Okay. For a pair of medium, that is we are taking air and glass. Glass is the denser medium. Now the second example, if you are taking air and water medium. Okay. Critical angle for the pair of medium, air and water. For water, we know the refractive index. Refractive index of water with respect to air is equal to 4 by 3 or 1.333. Okay. Now, we have sin C is equal to 1 by 4 by 3, which is 3 by 4. To get the critical angle C value, you have to take the sine inverse of 3 by 4. Okay. And the value will be 49 degrees. Okay. For glass, the critical angle is 42 degree, glass, air, medium, and air, water pair of medium will be having the critical angle should be equal to 49 degrees. Okay. What are the factors affecting the critical angle? The critical angle for a given pair of media depends on the refractive index. How does it depend? What is the relation? We have sine of critical angle equal to 1 by refractive index of the medium, which means this is a reciprocal relation, right? It is an inverse relation. Now, the first factor is dependence on the color of light, which means dependence on the wavelength of light that is used. Okay, what is the relation between wavelength and refractive index? They are also in an inverse relation. When refractive index increases, what happens to wavelength? Wavelength decreases. Or when wavelength increases, refractive index decreases. Okay, so when wavelength increases, refractive index decreases. When refractive index decreases, critical angle will increase. Okay, here if you are taking violet, indigo, blue, green, yellow, orange, red, which light has the highest wavelength? Highest wavelength is for red light. Okay, and minimum wavelength is for violet light. What about the refractive index? Refractive index will be minimum for red and refractive index is maximum for violet. Now what about the critical angle? When the light used is a violet light, the critical angle will be minimum. Okay. And when the light used is a red light, the critical angle will be maximum. So what is the relation? When wavelength increases, critical angle increases, and when wavelength decreases, critical angle decreases. So this is the relation. Okay. Critical angle increases with increase in wavelength. Okay. Now the second point is dependence on temperature. When temperature changes, what happens to critical angle? There is nothing to remember. This is critical angle increases with increase in temperature. So to increase critical angle, what we need to do is just increase the temperature. So these are the two factors. Okay, now we can define total internal reflection. What is total internal reflection? We know that when light travels from a rarer medium to denser medium, there is partial reflection and refraction occurring always. But when the light travels from denser to rarer medium after a particular angle of incidence, which is angle of incidence is equal to critical angle, when angle of incidence becomes more than critical angle, then no more refraction is going to take place. Only reflection will take place. And this type of reflection is called total internal reflection. Here, this is the first case when angle of incidence is less than critical angle. What is happening? Both reflection and refraction is happening. Okay. So, here when the angle of incidence becomes equal to critical angle, the angle of refraction is 90 degree, and then at that point we call the angle of incidence to be equal to C. And this is the third case where the total internal reflection is shown. Okay. How is total internal reflection happening? When the angle of incidence becomes greater than critical angle. When a ray of light traveling in a denser medium is incident at the surface of a rarer medium at an angle of incidence greater than the critical angle, for the pair of media, the ray is totally reflected back. So, you can see the ray totally reflected back. There is no refraction taking place into the denser medium, and this phenomenon is called total internal reflection. Okay, remember, total internal reflection will take place only when the light is traveling from a denser medium to rarer medium. Clear? Now, what are the two important essential conditions for total internal reflection to happen? The first one is the light must travel from denser to rarer medium. If light travels from rarer to denser medium, this is not going to take place. Okay, first condition is light should travel from denser to rarer medium. And the second is the angle of incidence must be greater than the critical angle from the pair of medium. Okay, so if angle of incidence is less than critical angle or angle of incidence is equal to critical angle, then total internal reflection cannot happen. When angle of incidence becomes greater than critical angle, only then the total internal reflection can happen. Also, when light travels from rarer to denser medium, there is no total internal reflection. When the light travels from denser to rarer medium, also the second condition should also be followed, that is, and the angle of incidence becomes greater than critical angle, total internal reflection will take place. Clear? So, you have to remember one important point. You know, reflection is taking place in case of plane mirrors. But here the importance is, where do we find the application of total internal reflection? Total internal reflection will find application because here 100% of energy or 100% intensity of the incident light will be equal to the intensity of the reflected light. Okay, there is no wastage of energy or wastage of the intensity of light taking place here. In case of plane mirrors, absorption can take place, also the refraction can take place, but here only reflection is taking place. Okay, what is the intensity of incident light? The same intensity will be there for the reflected light. Okay, so this is why, because of total internal reflection, there is many applications. It is used in case of periscope, then binoculars, also in fiber optics. Optical fibers, to make optical fibers, this total internal reflection, application of total internal reflection is used. Clear? Now, we will be discussing how total internal reflection will happen in different types of prism. Three types of prism we will be discussing. First is right-angled isosceles prism, then we have equilateral prism and right-angled prism. So, in case of right-angled isosceles prism, three cases we are discussing. First is to deviate a ray of light through 90 degree. Okay, so this is a right-angled isosceles prism. In case of isosceles prism, what does isosceles mean? What is an isosceles triangle? A triangle with two sides equal is called an isosceles triangle. Okay, and it is given, we need a right-angled isosceles triangle, which means equal sides. Between the equal sides, the angle will be equal to 90 degree. When it comes to prism, so here we have the principal face. Okay, so in this face, you will be having this angle to be equal to 90 degree and these two sides are equal. Okay, also these angles will be 45 degree. So, we have studied the angle opposite to equal sides are equal. Here we have 90 degree. In a triangle, we know the total angle will be equal to 180 degree. Also, these two angles are equal. If you take it as x, we will be getting x plus x, 2x. Okay, 2x plus 90 degree equal to 180 degree, which means 2x is equal to 180 degree minus 90 degree, which is 90 degree. Then x will be 90 degree divided by 2, which is 45 degree. This is how you are getting two angles 45 degree and one angle to be 90 degree in case of an right angle isosceles prism. Okay, let's see how the light gets deviated by an angle of through an angle of 90 degree. Okay, here we have two refracting surfaces. Okay, AC and CB are the refracting surfaces. Okay, so these are the equal sides of the isosceles triangle. Okay, and here this is the hypotenuse. Why? Because we have a 90 degree here. Okay, XY is your incident light. Okay, here you can see normal incidence. What does normal incidence means? The angle made will be 90 degree. Okay, the angle of incidence will be 90 degree. Then what happens? For normal incidence, we know that the refraction won't take place. There is no refraction happening, zero refraction. The light ray will go undeviated. There is no deviation. So, XY will pass undeviated. Okay, so it reaches the face AB. Now what happens? Here what is the angle of incidence? We need to find the angle of incidence. For that, we will be drawing a normal. Okay, this is your normal. Now consider here this triangle. Let's mark this as O. This point as O. AYO. Consider triangle AYO. Here we have 45 degree. This is 90 degree. Okay, then what is this angle? This angle will also be equal to 45 degree. Okay, here we have drawn a normal. For a normal, we know this total angle will be 90 degree. If this part is 45 degree, then this part should also be 45 degree. Okay, here we have the incident ray. Okay, incident ray for this surface. This is the incident ray. YO is the incident ray. And this is your normal. Angle between incident ray and normal is your angle of incidence, which is equal to 45 degree. What about this angle? Here what is happening? We are getting 45 degrees. Right? We know that the critical angle here, this prism is made up of glass. We have studied the critical angle in case of glass is equal to 42 degree. Okay, and our angle of incidence is equal to 45 degree. 45 degree is greater than 42 degrees. Yes. If 45 degree is greater than 42 degree, we can say angle of incidence is greater than the critical angle. When angle of incidence is greater than the critical angle, there is no refraction going to take place, and here we will be having total internal reflection. This light ray will completely get reflected. Okay, total internal reflection will happen. So when reflection happen, we know the angle will be 45 degree. Angle of incidence and angle of reflection should be equal. Okay, so this is your reflected ray. Okay, reflected ray reaches this face, that is CB. Now what happens? Here it is normal incidence. Okay, this angle will be 45 degree. So when you consider here this triangle, since this is normal and this part is 45 degree, you will be getting 45 degree here. Okay, 45 degree, then the other angle should be 90 degree, which means here again normal incidence is happening. Normal incidence is happening and the light ray will come out like this. Okay, now if you consider another ray, okay, here if you have an object, so this is the head. Okay, you are considering from the other end another ray of light. This is normal incidence. It will pass undeviated, reaches this face, total internal reflection will take place. Again, it will come out. Okay, so here let's say this is AB. This is A. Here we'll be able to obtain the image of A. Here we have B. This is image of B. Okay, so if you are looking from here, if you are looking at the object from here, the object which is at this point can be obtained. Okay, which means the light is deviated through 90 degrees. And here this finds application in case of periscope. In periscope, this is used. If you can look from here, you will be able to see the object which is at this point. Okay. Now the second case, here again we are using the same right angled isosceles prism to deviate a ray of light through 180 degree. Okay. Here we have the figure. Now this is your object PQ. Okay, so the ray of light from PQ, this is your incident light, it is going to the face AC of the right angled isosceles prism. Okay, so first let's consider the ray from P. So this is the first ray. Here what is happening? Normal incidence is taking place. Normal incidence 90 degree. The light ray will go undeviated. Okay, so the light ray will go undeviated. It reaches this point. Now what happens? At this point, when it touches the face AB, what is happening? You can draw a normal. This is your normal. Okay, so here the total angle will be 90 degree because this is your normal. When you consider this triangle, here we have 45 degree, this is 90 degree. So this angle should be 45 degree. If this angle is 45 degree, total angle we have 90 degree, this part should be 45 degree. Okay, if this is 45 degree, now we have glass. For glass refractive index, we know refractive index is equal to 3/2 and the critical angle is 42 degrees. Okay, if the critical angle is 42 degree, here the angle of incidence is equal to 45 degree. Angle of incidence is greater than critical angle. 45 degree is greater than 42 degree. Therefore, total internal reflection will take place and the angle of incidence and reflection angle will be equal. This part becomes 45 degree. Okay, this part is 45 degree. Here also we will be having 45 degree because this is a normal. Here we have 90 degree, which means in this triangle, this part should be 45 degree. Okay, now what happens? Total internal reflection takes place and this is how the light ray goes. Okay, light ray comes and strikes here. Now this is your incident ray for this phase BC. Again what happens? We'll be drawing a normal. Okay, and find the angle. If this is 45 degree, this part should be 45 degree because total angle is 90 degree. We are getting angle of incidence to be equal to 45 degree. 45 degree is greater than 42 degree. Again total internal reflection will take place. So this is total internally. The ray is internally reflected. Now what happens? Angle of incidence and angle of reflection will be 45 degree. Again this is normal 90 degree. This part is 45 degree because I is equal to R. And this part also will be equal to 45 degree. Okay, 45 degree, 45 degree. Therefore this should be 90 degree. Normal incidence is happening and the ray will come out undeviated. Okay, so for P you are getting P dash here. Okay, now every rays of light from this object, if the object is like this, from every point the light ray will undergo the same type of total internal reflection. Now even if we start from Q, we have normal incidence. This is normal incidence. Here what happens? Same angle. If you draw a normal, we have 45 degree angle of incidence, 45 degree angle of reflection, total internally reflected. The same light ray will be incident on the face BC. Now what happens? Again normal 45 degree, total internally reflected. The light ray will come out undeviated. So for the object PQ, we are getting P dash Q dash. Okay, what has happened? We are getting an inverted image. Okay, just an inverted image, that is 180 degree rotation has taken place. Okay, if you have AB becomes the mirror image, that is BA. Okay, just the mirror image we are getting here. QP becomes P dash Q dash. Okay, this application of this is in case of binoculars and in camera. Okay, the intensity of the incident light, the object's intensity will not reduce. You will be getting the same image, but what is happening? A 180 degree change will happen. Okay, clear? Next, the third is to erect an inverted image without deviation. So here again we are using the same right angled isosceles prism. So this is your prism. Here we have the angle 90 degree. These two angles are 45 degree. Equal sides are BA and BC. Okay, we have an object PQ which is an inverted object. We are going to get the erect image of this inverted object in the opposite side. Okay, now consider incident light rays from P. Okay, this is the incident ray. Here there is no normal incidence. What happens? Light travels from rarer medium to denser medium. When light travels from rarer to denser medium, it bends towards the normal. Here this is the actual direction in which the light should have traveled. But what happens? Due to change in medium, rarer to denser, light ray bends towards the normal. This is your normal. okay, and it will be traveling to the base of the prism. So this is your refracted ray. Now what happens? Here when you consider this triangle, in this triangle we have an angle 45 degree. What about this angle here? We already have 90 degree normal, okay. So here this angle is 90 degree and this total angle will be greater than 90 degree. If this is greater than 90 degree, let's say this is 100 degrees, okay, 100 degrees plus 45 degree, you will be getting 145 degree. Then this angle will be 180 degree minus 145 degree, which is equal to 35 degree. Okay, so here this ray of light is incident. We can draw a normal. What is the angle of incidence then? This angle will be getting a value which is less than 45 degree. If it is equal to this angle, if it is 90 degree, then you will be getting 45 degree. This angle is greater than 90 degree. Therefore, this angle should be less than 45 degree. Here the total, this is a normal. Total should be equal to 90 degree. Okay. If this is 45 degree, this will also be 45 degree. But here we have an angle which is less than 45 degree, which means this angle will be greater than 45 degree. Okay, because the sum should be 90 degree. Let's say if this angle is equal to 30 degree, then this will be 60 degree. Okay, the sum should be equal to 90 degree. Okay, we are getting a value which is greater than 45 degree. If the angle of incidence is greater than the critical angle, in glass the critical angle is equal to 42 degree, we are getting a value of angle of incidence which is greater than 45 degree. Greater than 45 degree means surely it will be greater than 42 degree, right? Therefore, the angle of incidence is greater than 42 degree. Angle of reflection will also be equal to 45 degree. Total internal reflection will take place. And this is your ray of light. Okay, total internal reflection, this is your ray of light. Now again what is happening? Now it is going to get refracted. Okay, light is traveling from denser to rarer medium. Here we have the normal. This is the actual direction in which the light should have moved. What happens? It bends away from the normal. Okay, so here for P we are getting P dash. P dash is obtained here. Okay, now same in case of Q. This is the incident ray. To the base it gets refracted. After that total internal reflection will take place. This is your reflected ray. Reflected ray reaches the face BC. Again refraction happens. So here we are getting the erect image. Okay. So for PQ we are getting Q dash P dash, which is the erect image. And the application of this is in case of slide projectors. In slide projectors, this is being used. Okay. Next is the total internal reflection in case of equilateral prism. What is equilateral prism? We know what an equilateral triangle is. A triangle with all sides equal and all angles equal to 60 degree is called an equilateral triangle. Okay. So here we have the principal face. In this principal face, all angles will be 60 degrees. Okay. Now let's see how the total internal reflection takes place in this case. Okay. Here we have a parallel beam of light. PQ is your first ray and P dash Q dash is your second ray. Okay. What happens to this PQ? We have normal incidence. Angle is 90 degree, which means the ray will go undeviated. Okay. Undeviated ray. Now what is this angle? This angle is 90 degree. Okay. For an equilateral prism, all the angles of the prism will be 60 degree. Here we got 90, here we got 60. Therefore, this angle should be 30 degree. Okay. When the light ray strikes the face AC, we draw a normal. This is your normal, which means the total angle should be equal to 90 degrees. Okay. If this part is 30, then this part will be 60 degree. We are getting an angle of incidence which is greater than 42 degree. Angle of incidence is greater than critical angle. What happens? There is no refraction. Total internal reflection takes place. Okay. So this is the reflected ray. And the angle of reflection will be 60 degree. Again, the angle of reflection will be 60 degree. What happens to the ray of light? Here, it strikes the face BC. When it strikes the face BC, let's check. This angle is 60 degree. Okay. Then here, what about this part? Here we'll be having a 30 degree and this will be 30 degree, which means when you consider this straight line, in this straight line, we are having 60 degree here, 60 degree here. Therefore, this part should also be equal to 60 degree because on a straight line, we will be having total 180 degree. This part should be 60 degree. Okay. This small part will be equal to 30 degree. Why? Because here we have an angle of 90 degree. 60 degree plus 30 degree. Okay. This is 30, this is 60 and here we'll be getting 90 degree, which means normal incidence, the ray will come out undeviated. Okay, so this is your emergent ray. So starting from here, you are getting the emergent ray here. Now the second beam, P dash Q dash, that is considered falls undeviated, okay, to the base of the prism BC. Now what happens to this? Here, we'll see the angle. This is 90 degree, 60 degree. This part should be 30 degree. Drawing a normal, we'll be getting this equal to 60 degree. Okay, angle of incidence is greater than critical angle, 60 degree. Angle of reflection will also be equal to 60 degree. Now what happens to the ray of light? The ray of light will move in this direction. Okay, when it goes and strikes here, what happens? Again, it will emerge out. Same thing. So this is what happening to the parallel beam of light. One ray will be coming through this phase and the other ray will pass out through this phase. Okay, that is, you are making an angle of 180 degree between them. Clear? This is the case of an equilateral prism. Next case is total internal reflection through a right angled prism. Okay, this right angled prism, you have to remember in the previous case we had a right angled prism such that two angles is 45 degree and one angle is 90 degree, which is isosceles, right angled isosceles prism. Here how it is, we have one angle 90 degree and the other two angles sum is equal to 90 degree. 30 degree and 60 degree. 30 plus 60 is equal to 90 degree. Now let's see how total internal reflection is going to take place in this case. Okay, so here first we'll consider the phase AB. Okay, incident ray. Let's take a ray of light which is incident at AB. What happens? Normal incidence. Normal incidence means the light ray will go undeviated. Okay, and then it strikes a phase AC. When it strikes a phase AC, what happens? You will be able to draw a normal. Let's say this is your normal. Okay, now considering this triangle, you have 30 degree here. Then you have 90 degree here. 90 plus 30, which means this part will be 60 degree. This part is 60 degree. If this part is 60 degree, here the total, because of normal, total will be equal to 90 degree. This small portion should be 30 degree. Okay. Angle of incidence is 30 degree. If angle of incidence is 30 degree, can total internal reflection take place? No, right? Because the angle of incidence is less than 42 degree. Angle of incidence is less than critical angle. There is no total internal reflection taking place. So, in case of a right angled prism, if you are considering the phase AB where the angle is 30 degree, okay, one angle is 30 degree, in that case total internal reflection will not take place. Okay. Now the second case, let's consider AC as the phase. Okay, we are considering AC phase. Here we have an incident ray. This is normal incidence. Okay, normal incidence, the light ray will go undeviated. So this is your light ray. Okay, the light ray will strike the phase AB. Here we'll be drawing a normal. Okay, when you draw a normal, considering triangle, this triangle, here we have angle A 30 degree. This is normal incidence. Therefore, here we'll be having 90 degree, which means these angle will be 60 degree. Okay, we have drawn a normal. If this part is 60 degree, this portion will be 30 degree. Again, we are getting the angle of incidence to be equal to 30 degree. If angle of incidence is 30 degree, we know that 42 degree is greater than 30 degree, which means angle of incidence is less than the critical angle. 30 degree is less than critical angle. Therefore, here also the total internal reflection will not take place. Okay, when you consider the phase AC such that one angle is 30 degree and the other angle is 60 degree, in that case also total internal reflection is not taking place. In phase AB, when the light is incident, and on the phase AC, when the light is initially incident, total internal reflection will not take place. Okay. Now the third case, that is, here we have the incident ray. PQ is your incident ray. Light is incident on the face BC. Okay. What happens? It will travel undeviated. Okay. It will travel undeviated. So here we'll be drawing a normal. When you consider the triangle, this part is 60 degree. Here we have 90 degree, which means this small angle will be 30 degree. Okay. When you draw normal, total should be 90 degree. If here we have 30 degree, this part will be equal to 60 degree. Yes. So 60 degree is your angle of incidence. If angle of incidence is 60 degree, which means 60 degree is greater than 42 degree. 60 degree is greater than the critical angle. Angle of incidence is greater than critical angle. Total internal reflection will take place. Okay. Reflection is taking place. We are getting the angle of reflection to be equal to 60 degree. Okay. Now the light ray which strikes this point, what happens? What happens? Here the light is travelling from a denser medium to a rarer medium. Is it normal incidence? No, right? Here we have 90 degree and this part is 30 degree. Okay. Since this part is 30 degree, we'll be having the light to be getting refracted. Okay. Light ray. So this is the actual direction in which light ray should have travelled. When you draw normal, it will bend away from the normal. Okay. So this is your emergent ray of light. Understood? So here, remember one thing, only when you consider this phase BC, you will be getting total internal reflection to happen. Okay. When AB and AC, light ray is incident on AB and AC, total internal reflection is not going to take place. We know that reflection will happen when you have a plane mirror. Then why considering this total internal reflection? Let's see the distinction between total internal reflection and the reflection from a plane mirror. First point is, it takes place only when light passes from a denser to a rarer medium at an angle of incidence which is greater than the critical angle for that pair of medium. That is the definition of total internal reflection. Okay. Now, in case of plane mirror, it takes place when light is incident on a plane mirror from any medium at any angle of incidence. That is, angle of incidence and the medium doesn't matter. Okay. Plane mirror, in case of plane mirror, reflection can take place. But here we have two important conditions. Light should travel from the denser to rarer medium and the angle of incidence should be greater than the critical angle. Now the second is, the entire light is reflected. Here what happens is, only a part of light is reflected. Okay. While the rest of it gets refracted or absorbed. Here in case of plane mirror, absorption can take place, also refraction can take place. But here the entire light is getting reflected. Third point, there is no loss of energy. Important point, there is no loss of energy. The energy of the reflected ray is the same as that of incident ray. Incident ray's energy and reflected ray's energy will be equal. But when it comes to the case of plane mirrors, there is a loss of energy. We said refraction and absorption to be taking place. The energy of the reflected ray is always less than that of incident ray. Why? Because this energy is getting divided into the refracted light. It is getting absorbed and there is reflection. So only a portion becomes reflected light. Both other energies, that is refracted and absorbed, are wastage energies. Okay. Next, the image is much brighter and the brightness remains unchanged even along long use of the total reflecting device. Now the fourth point, the image is much brighter and the brightness remains unchanged even along long use of total reflecting device. Even though this reflecting device is being used for a long time, the brightness will be same. It will remain unchanged. What about the case of a plane mirror? The image is less brighter and the brightness gradually decreases as the silvering on mirror becomes old and rough. Okay. So when time passes, what happens? In case of plane mirrors, the brightness of the image is decreasing. Here the brightness will remain the same. Got it? So these are the four important points for distinction between the total internal reflection and reflection in case of plane mirror. Why using total internal reflection in place of why is total internal reflection better than the reflection in case of plane mirrors? Okay, that's all for today. In today's class, we have studied what is critical angle and how total internal reflection will take place, and we have studied the applications of total internal reflection. Hope you all enjoyed this session. I'll be back in the next session with a new chapter. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.